Okay, babies, so we are looking at page 2 of your notes, and I'm just going to talk you through one of the parent functions so you'll kind of get an understanding of what you need to focus on when you're studying your other parent functions. So if you will look, we are going to look at the quadratic function. And its equation, of course, looks like this, x squared. We're very familiar with this. If we were to make a table of values, remember how we do that. I choose a value for x and I substitute it in for f of x. So in other words, these are the x values right here, and these are going to be the x squared values right here. So I'm just going to pick some things that, we're very familiar with. Okay, so there's my table of values. So what does that look like graphically? Well, it looks like this. I've got a 0, 0 here, 1, 1, negative 1, 1, 2, 4, negative 2, 4. If we were to go farther out, let's say 3, well, 3 squared is 9. So at 3, I'm going to be up at 9. And at negative 3, I'm going to be up at 9. So here's my parabola. And I'm not doing a great job with my graphs, but that's okay, it's fine. All right, so what are the characteristics? Pretty much if you can graph one of these, you can figure all of this out. So our x-intercepts, well, that's gonna be the origin for the x and the y-intercept, so that's pretty easy. Your domain, that is all of your x values. Well, notice it's all above the x-axis, so that means it covers all the positive values for x's and all the negative values for x's. So our domain is going to be negative infinity to positive infinity. And then for the range, notice that the range, we are not dealing with any values down here in the negatives. So our range is going to be bracket 0, positive infinity. So it's a bracket at 0 because it includes it. All right, so your domain and range, you have to pay attention to brackets versus parentheses. So as we scooch up here and look at some other things that may not be as familiar to you, we are looking at absolute extrema. So what does that mean? It just means that we have values that reach a maximum or a minimum. In this case, we don't have a maximum, so I'm just going to write DNE here for does not exist. We do have a minimum value, though, that the graph will go. The graph does not dip below 0, 0, so that's its minimum absolute value. Okay, so let's talk about continuous or discontinuous. Well, if you noticed the way I drew it, it was continuous because I didn't pick up my pencil. Remember we talked about that in one of the other videos. I think the last one. Didn't pick up pencil. So that means there's no holes, gaps, nothing like that in the graph. So it is continuous. Increasing, decreasing, or constant. Well, from right to left, let's look at this. I'm decreasing here, and then I'm increasing right here. So it is doing both of those things. Even, odd, or neither. I'm going to explain this in more detail later, but it has to do with symmetry. All right, and since a parent function of a parabola has symmetry about the y-axis, it is considered to be even. So symmetry about the y-axis. Look at that. Beautiful. Okay, end behavior. Well, end behavior, let me revisit the graph. End behavior indicates what's happening right here. Well, if you'll notice, it's going on forever this way and forever this way. So that is an indicator as to what my quote end behavior would be. The way we think about this is as x values are approaching positive infinity, what's y doing? Well, it's doing the exact same thing. Let me draw that here so we can look at that. So here's my parent parabola, my parent quadratic function. X is approaching positive infinity this way. So that means this right here. Because won't this eventually spread out and be going that way. So that's what we're thinking of as positive infinity. Well, how's y responding to that? It's also going to positive infinity. On this side, x is approaching, you guessed it, negative infinity, if I could draw that. And y is responding by still approaching positive infinity. So again, like I've said in another video, and I said at the beginning of this one, if you can establish what the graph of the parent looks like, you can pretty much figure out all of these characteristics without thinking too hard about it. Okay, so I'm going to go ahead and look at page 3 of your notes, because by the time you get done with this video, it should carry you through some of the homework that I'm going to assign. So when we talk about the behavior of a function, we illustrate that with how we write it. So in math, we use a lot of symbols. So we like to keep things short and sweet. We don't like to write things out. So if I'm looking at set notation, that means a set of numbers. That means that we are going to use our inequalities, right? We are familiar with those. Okay, we're going to use inequalities in these. Let's say I have a value that's less than 1 and greater than or equal to -3. Okay, that is set notation. But we would write it in a true set as a set of all x so that -3 is less than, or x is greater than or equal to -3, sorry, and less than 1. Okay, so that's how we would write that as set notation. And it's just telling you that the answer is the set of all x values, but with this restriction. So that's what that's going to look like. Interval notation is a little bit easier to remember. Interval notation uses brackets and parentheses only. So the way I would write this, if x is less than 1 and greater than or equal to -3, it would look like this. Since it's greater than or equal to -3, that's a bracket. Bracket always means it includes the value. And then, of course, since it's just less than 1, I'm going to have parentheses. So they mean the same thing, it's just they're written in different notation. And if you'll think about it in terms of the number line, let's see what this would look like. So if I've got 0, 1, 2, 3, -1, -2, -3. I don't know why I wrote those in that weird order. Okay, so if I was going to graph this, at -3, I would have a closed-in circle because it includes that value, and then I would draw all the way to +1, but it's going to be an open circle because it does not include 1. So that is how we write that. And again, let's remember the end behavior like I wrote right up here. Okay, there's our end behavior. We always write it just like that with arrows. And it just means as x approaches, and guess what? X is always going to approach positive or negative infinity. All right, y approaches something. It doesn't have to be infinity in response. That's why we call it the response variable. You with me? Okay, you're all done with this video. Sorry this one was a little long. Ooh.